Now I'm sharing my screen. Good morning, friends. Whoever is on Hangout, we'll start in a moment. I hope everyone can see my screen. And let me start the live chat. So whoever on YouTube live, if you guys want to join the WebEx session, if you want to discuss with me about big data anytime later, you can actually use this link to join the WebEx meeting. I'm sharing the link in the chat of YouTube live. Okay, so this is the link which you can use to join the WebEx meeting. Whoever is on live, if you guys want to join. Okay, so let us start. I hope everyone on WebEx invitation can see my screen and also can listen to me. Once someone acknowledges, I will start. Hello, on WebEx, can you guys hear me and can you guys see my screen?
Yeah.
Okay, thank you. So let us start. So this is about big data introduction. I have been getting a lot of requests about having idea about big data, and there's a lot of confusion. What is big data and what is data science, etc. So I thought of conducting a introduction session. Already I have some videos on my channel, but they are a little bit outdated. I want to explain the current state scenario of big data. That's why I'm conducting this session. Okay, so as part of the agenda, we will you will understand about me, and then we will actually go through the topics. So I am a 13 plus years of I'm an IT professional with 13 plus years of experience in vast array of technologies, including Oracle, Java, J2E, data warehousing, ETL, BI, as well as big data. I have tons of certifications. I have certifications in Oracle, I have certifications in data warehousing, and I have certifications in big data. So I run a website called itversity.com and a channel called itversity. You can go to YouTube and search for itversity. You will get my channel, and you can reach out to me on any of the social networking platforms. And these are the meetup invitations. So before getting into big data, I have implemented quite complex data warehouses successfully. And 4 years back, I transitioned myself into big data. Out of 13 plus years of experience, majority of my experience is in US, and I worked for clients like AT&T, Citigroup, IBM, and many other Fortune 5 companies. 1 minute, this guy could not hear me. Okay, for past 4 years, I am working in big data. I have worked on Hadoop. I have worked on Spark. I have worked on many other technologies, and also I am a certified uh, uh, cloud foundry trainer. I have extensive knowledge in cloud also. So as of now, my primary focus is both on big data and cloud. Recently, I quit my job and I am spending full time in itversity, and I want to build my company in 2 phases. So first of all, itversity is a Dallas-based startup, and we want to get into the industry in 2 phases. As part of phase 1, we want to build an online platform where anyone can learn technology for free. And as part of phase 2, I want to get into staffing, so that leveraging the talent pool which I get on my IT varsity platform, education platform, I want to get into staffing by mitigating some of the inefficiencies in the staffing area. So you will understand as we proceed. If you follow me, I will keep on publishing what are the issues we are trying to solve in the staffing area. I want to get into staffing solutions. It's a little bit out of context and I don't want to get into it as of now. But starting from 2018, we will focus on staffing also. So now let us understand the rationale behind big data, why we have to explore big data. Okay. For that, first we need to understand what kind of applications we find in enterprises. In enterprises, typically we have a operational applications and decision support applications. Means if you follow the industry for past 15 years, earlier most of the applications are operational, which means some of the business use cases are migrated into IT using Java J2E or Microsoft technologies, and most of the use cases are business are related to the core businesses of the enterprises. For example, if it is a retail store, they want to automate several things. Whether it could be their supply chain, it could be the point of sale, it could be anything. Similarly, when it comes to banking, they want to reduce the traffic to the banks and do the online transactions. Hence, they provide the facility to transfer money from one account to another account online. Okay, so they are all operational use cases. And then decision support, if someone in the executive management want to understand how the business is doing. For example, same retail store, if you want to if it is a multi-chain multi-store retail company, there will be multiple stores across the globe or across the nation, and someone want to see how each store is doing, or how the stores in a particular region is doing. So by looking into those details, some executive management can make certain decisions to improve their businesses. Okay, so that's what decision support is all about. So typically, these are most of the enterprise applications can be categorized into these two: either business critical or transactional applications, which are considered as operational, and then second one, decision support, where executive management can understand how the businesses are going. But for past 1 decade, after success of Google and social networking platforms such as Facebook, LinkedIn, smartphones, etc., there is another set of applications that are being built in the enterprises, and those are called as customer analytics. So here it is very important to understand the difference between decision support and customer analytics. As I mentioned to you earlier, decision support is all about understanding how the business is going and making certain decisions to improve the business. Okay. Whereas customer analytics, it's all about how customers are spending their money. So there is a difference. One major difference is in decision support, only handful of users will be having a look at the reports that are generated so that they can make certain decisions. Whereas when it comes to customer analytics, each and every customer want to see how he is spending the money. For example, let's say you buy products in Amazon. You spend $2,000, $3,000 in a year to buy several products in Amazon. If Amazon provides a report saying on which categories you are spending money, whether you are spending in electronics or apparel or whatever it is, it will you can make better decisions next year when you budget as a person for next 1 year to buy several products in Amazon. You can understand based upon your past behavior, and you can make better decisions. Another classic example is mint.com. There is a website called mint.com in US where they take your credentials of your credit card accounts, bank accounts, etc., and they categorize how you are spending money using several credit cards, how much you are spending for entertainment, how much you are spending for travel, etc. So based on those categories, you can even set the limits, and if you cross the limits, Mint actually send the alerts also that you have crossed the limits, etc. So that is all customer analytics. These three are the types of categories of applications that are being developed as of today. One is operational, which covers core business. Second one is decision support, primarily for executive management, where they can look into the reports and make certain decisions in future. And customer analytics is third category, where each and every customer of an organization gets the report of his behavior, so that he can make his decisions. He can make better decisions in future. Okay, and then we need to understand what is the architecture of these enterprise applications. Most of the traditional applications, when I say traditional, either they're transactional or decision support. Either they are core business applications or enterprise data warehouse applications. These traditional applications are considered as monolith, and they typically follow NTR architecture. There are exceptions. For example, if it is mainframes, you don't find NTR architecture in there. If they are not mainframes, typically they use database called RDBM, database called Oracle, and it is categorized under RDBMS, Relational Database Management System. But modern applications use microservices and considered to be polyglot. When I say polyglot, it means that if you take a website or an application, it will have many modules, and each module might work better by using different type of database. Earlier, all the data used to store only in RDBMS or mainframes, but now we have many other options, such as NoSQL, such basic databases, in-memory databases, graph databases. There are many types of databases these days, and all the modern applications which use microservices, each microservice will be pointing to a different type of database, or is capable of pointing to a different type of database, so that the performance will be optimal for each and every microservice in a given website, such as Amazon, LinkedIn, etc. I will take an example and I will explain a little bit later. But keep in mind that modern applications use microservices as architecture and considered to be polyglot, which means that each microservice or each module of an application can point to a different type of database. One can point to RDBMS, one can point to NoSQL, one can point to in-memory cache, etc. We will see all the options we have from the databases a little bit later. And all these things are related. So even big data is related to this, and most likely big data is categorized as database, or it actually provides options of databases other than RDBMS. Okay, so let's take the example of e-commerce platform, and let us understand what is operational. So operational can be categorized into transactional and not transactional. So first we need to understand what is transactional. So when you go to Amazon, let's take the example of Amazon.com. You go to Amazon, you buy the products, or you search for the products, and you add them to cart, and you check out from the cart. What will happen? It will ask for your credit card information. You have to pass your credit card. Money will be debited from your credit card and credited to Amazon, and order will be placed on behalf of you, and you will get the products in few days. So this is a transactional use case, and all this information is very critical. It has to be stored in a highly reliable database, and hence typically even Amazon uses databases such as RDBMS or some other relational database which is highly reliable, and they spend huge amounts of money so that they don't lose any transactions. Okay, that is one use case which is considered as operational and transactional. But if you go to same Amazon.com and if you try to search for a product, it's an operational use case. When you search, you have to get the results immediately. On top of the products which you are planning to buy, you get the recommended products. Okay, they say people who bought the product you are searching also bought so and so. For example, if you try to buy 55-inch Samsung LED TV, And they might recommend a music system of Bose or some other premium brand. And most likely, people who want to buy Samsung want to buy high-end music system, and this is called as recommendation engine. And it just recommend based on a category affinity or price affinity, or and there are different types of affinity which Amazon or any other e-commerce platform tend to recommend to you. So those that search use case and getting the recommendations is called as recommendation engine. Okay, so these two we can visualize these two kinds of applications in e-commerce platform. One is checkout, which is transactional. Second one is recommendation engine. And then decision support, sales trends. So if Amazon executives want to see which category they're performing better, whether they're performing better in electronics or in apparel or whatever, or groceries. So there are many categories where Amazon send their products, and if they want to understand the behavior of based on certain criteria, they can actually look into the trends, and that is categorized as decision support. Okay, and then customer analytics. So typically there are many prime Amazon customers who pay $100 per year and spend thousands of dollars every year to Amazon. Okay, and as a user, every one of us want to understand how we are spending. On top of us, there are vendors in Amazon who sell products through Amazon. Okay, and they want to see their reports, how their businesses are performing. So there are two types of customers for the companies like Amazon. One is the buyers, who are we, who buy the products from the platform, and the other one is sellers, who actually have their warehouse or go down and start selling the products from their warehouse or go down by becoming a vendor as part of Amazon. So there are two types of customers, and both type of customers want to see how their behavior is. Buyers like us want to see where they are spending money, and vendors have to see how their businesses are doing. Okay, and we can categorize it as customer analytics. And now most of the inputs, whether it is recommendation engine or sales trends or customer analytics, are sourced from the operational systems only. Operational systems such as checkout, and also the visitor traffic when people go and visit the website and search for a products. That information is also considered as operational. So those two types of data, which is the checkout data as well as the visitor traffic, can drive most of the use cases such as recommendation engine, sales trends, customer analytics. Everything is driven by those two. So here you need to understand that transactional data typically from the database come from the database, and then visitor traffic is not stored in any database. If they start storing in a database, then the performance will be bad, and also over time the database will explode. To avoid that, what they do is all the visitor traffic Amazon logs into web servers, and we have to get that data from web servers, integrate into downstream applications, and then we can do whatever we want. So what we need to understand is even the decision support and customer analytics, in some cases all the non-transactional applications tend to get the data as input from transactional based systems or other operational use cases such as visitor traffic. So we will see how. So the bottom line is you have to have a data integration from these operational systems into other things, so that we can actually run our analytics or perform whatever task we want to do. We'll get into the details later. I'm deliberately not using big data because big data is nothing but a group of technologies. But as an application developer or as a data engineer, you should not focus on big data primarily. You should focus on the data integration, how the data is integrated from different sources into Hadoop or into the target systems. So you need to understand those things rather than rather than focusing on big data. You will get to see a little bit later. Okay, so data from the bottom line of this slide is data from transactional systems need to be integrated to non-transactional decision support and customer analytics, etc. Now comes data integration. Data integration can be categorized into real-time and batch. Okay, traditionally, when there are no customer analytics and recommendation engines, we used to have an ODS, which is used for compliance and single source of truth. ODS stands for Operational Data Store. EDW, where you will have your tables in dimensional model, facts and dimensions to support your reports. ETL, to perform transformations and load data into EDW or whatever target system is. And then BI, to visualize and publish reports. Okay, so these are the things which you need to keep in mind when it comes to data integration. Okay, at any point, if you have any questions, please ask those things in the chat. Okay, whoever on YouTube live, I will not be able to interact with you because WebEx is the first priority. 1 minute. You should be able to log in, Gopi. I don't know why you are not able to. You just have to right click on the link, copy link address, and then go to a browser and paste that link.
The problem is solved. Sorry.
Okay. Okay, sure. Okay, so anyone who have questions, who are on YouTube live, if you join a little bit late, you feel free to connect to the WebEx meeting if you want to ask questions directly on WebEx. Or at any point in time, if you have any questions, especially for those who are on WebEx, they can ask me on the chat. Open the chat and you can ask me the questions. Okay, so let's understand the architecture of data integration. You have different source systems. The source systems can be OLTP, which is a database that which stores the checkout information. In some cases, or in some enterprises, we use mainframes also, and then we need to get data from external applications. So when I say external applications, it could be web servers or application servers where the information is logged, or it could be flat files from the external companies. For example, if you are running a pharmacy store in US, you have to follow a lot of compliance rules. Okay, patient information and doctor's information will not be stored in the same database where the transactions happens. They only have an ID associated with the patient or doctor, but they don't have the other information. In some cases, for compliance reasons, they have to extract they have to extract additional information of doctors and patients, and there are third-party companies which will be able to provide you that information, and these pharmacy companies typically go to those companies to get data in flat files at regular intervals, and they integrate in their third-party applications and in their applications to provide some reports for the compliance purposes. Okay, so the data can the main thing which you need to understand is for external applications, data might come in weblogs where you can connect, where you can poll those weblogs and get the data out of it, or it can come from the flat files from the third-party vendors. And when it comes to flat files, the files could be XML formatted, the files could be delimited, the files could be JSON, the format could be anything. Okay, and we need to make sure that we have the framework to integrate data into the downstream applications. Now, even though I term it as EDW or ODS, you can think of any downstream application where you can data from multiple sources. Okay, so irrespective of the use of irrespective of the way you use the data from these different sources, you need to have something called ODS. Okay, I will explain the purpose of a ODS in a moment. And then you need to have a target system. It could be EW if you are trying to build a decision support system for the top management. The target system could be EW. But with modern applications, the target system could be anything. It need not be EW. It could be other type of target system also, like big data. We will get back to that later. So and then we have a data integration layer. So ODS is nothing but a database. EW is nothing but a database. We need to get data from these several sources, and we have to cleanse the data. Cleansing means if there are any special characters, or if there are any unnecessary characters, we need to remove those things. We need to standardize the data. So for example, if a customer phone number is there in a database in mainframe systems, and also it comes from external applications, the phone number format could be different in different systems, and we want to standardize before storing into EW, so that if we have to search on phone number or a timestamp or date, we have one uniform way of doing it, and it will improve. It will bring efficiency while reporting. So one is cleansing, second one is standardizing, third one is transformations. So when I say transformations can be row level transformations. Standardization can be considered as row level transformations. And then you have group transformations, such as aggregations, sum, average, min, max, and many other things. And then we also have sorting and ranking. So these are the different types of transformations which we typically do. So to perform all these things, we neither do on the source systems. We can, if we want, we can do on the most of the transformations on the source systems, but we don't do, because if we try to do that, if you want to get it, let's say if you want to build a report to the executive management about the revenue for each store on daily basis. Okay, if you have to do that, if you have one centralized database, the revenue, the metadata of stores will be in some in one table. The actual transaction data might be categorized into multiple databases. Multiple tables in a database. I will show you an example. Okay, here I am going to. I am opening a data model so that I explain how complex it is to generate the same report from the source systems, and what needs to be done in the downstream applications to improve the performance. Okay, or to provide reports in an effective manner. Sure, I will conduct these sessions regularly. One person have asked me privately, kindly do let us know when you're going to carry it out next such online session. I will be conducting these things regularly. You connect me to on the meetup so that you get the invitation, and you RSVP, and you can actually be part of these sessions. And also this one is streamed in YouTube, and you will get this video in YouTube after the session is completed. I might not do regular sessions on this topic, probably once in a quarter, but for reference, if you join late and if you want to understand what is going on, you can actually watch the video in YouTube, and the URL to watch in YouTube is this one. Okay, so let me explain the data model now. So this is a very simplified retail data model. Here you can see you have orders. So let's say you go to Amazon and you might place an order. What are the characteristics of orders? You have a date on which you have ordered, and we have to store the customer ID. So you have to log in Amazon, or you can check out as a guest also, I guess, but mostly people log into the Amazon to actually do the transactions, right? So we have to store the order customer ID, and we have order status. Order status can be new, can be processed, can be in shipped, can be completed. It could be in any state. So these are the typical characteristics of orders. So all that information related to order will be stored in a table like this one. But then within an order, you might have n number of items, and each item, the quantity can be different. So for each order item, whatever attributes or characteristics you want to store, you have another table called order items. So you have order ID. In this, order ID is the child foreign key to orders, product ID, which is a foreign key to products table, and then quantity of the product price, and then subtotal. So these two are transactional data tables, and we have to join these two tables to get the revenue for each day. On top of that, if you want to get the revenue for each department for each day, you have to join these 5 tables. And if you do it on the database directly, on OLTP directly, what will happen is the join will be very expensive, and it takes very long for you to generate the report. And who are the viewers of this report? Typically, it will be executive management, the top bosses of the company, the CXOs or the VPs. And for them, the performance, if the performance is not good, your job can be at risk. On top of that, even if you fine tune in such a way that you can generate the report quickly, another disadvantage is it can impact your transactions or your core business. When you try to join these many tables on a huge data set, it takes a lot of resources, and it will start impacting your core business. Your core business transactions will become slower, or it can become even inconsistent or unreliable. So your business can be at risk. So we don't generate reports on OLTP directly. Okay. And also sometimes you cannot actually generate report from one system. You have to connect to multiple systems and then generate the report. So here, these are the to address these performance issues and all those things. On target system, we use something called dimensional modeling or denormalized data models. Okay. So in this case, if I have to generate the report, okay, if I actually get only order date, order item subtotal, and then join all these tables on regular basis and get the department ID, look up into the department ID, and look up into the departments table, get the department name, and store in a one flat table with few master tables to join, then the performance will be much better. So if I have to do it in dimensional model, what I will have is I will have something called fact table. In that fact table, I will have order date, I will have order revenue aggregated for the date. So for example, if at minimum I want to see the revenue per day, so my granularity is at day level. Okay, so I will store data, order date, order revenue. I will discard all the other information. So even if I have 1 million transactions happened on a day for each department, I will have only one record for each department for each date. Okay, so order date, the department name or department ID, and then order revenue for the day and department. So now my table will be much concise. There is no need to join too many tables when I try to generate the reports, and the performance will be much better. Okay, for that reason, we use something called dimensional modeling if it is the EW, which is nothing but a denormalized data model. And then we get data from all the source systems, perform ETL, and store the and port the data into the dimensional model. So from the normalized model, data will come through ETL layer and stored in EW in denormalized or dimensional model. Okay. So from source systems we get the data, but data will go first. Typically, will first go into ODS. ODS is used for two reasons. One is compliance, and second one is single source of truth. Okay. I will give you an example. Let's say you want to troubleshoot your report, whether it is correct or not. If the report is built based on data from different source systems, it will be a nightmare for you to troubleshoot the issue. Okay, because you have to log into each of these different source systems, and you have to identify from which tables data is being sourced, and it will be a nightmare to do that. Okay, and in some cases people will resist even to give you access. For that reason, first we will port the data into ODS. In ODS, we will not do much transformations. We just pull the data from source systems and store the data in ODS as is in the normalized model. And then we will actually do the ETL. So if there are any issues with your reports, we can go back to ODS and troubleshoot the issues. So ODS is used for compliance purposes as well as the troubleshooting your reports or downstream applications, which is created based on data from multiple source systems. Okay, so now we have the reporting layer, which are typically BA tools. Those tools will be connected to either ODS or EW and generate reports out of it. Sometimes we connect even to ODS to generate some ad hoc reports. Typically, the reporting tools such as BA, Cognos, Business Objects, Cognos, etc., will be connected to EW, and reports will be generated out of it. Okay, so that is the typical data integration architecture. And now let us understand the technologies. If you want to do batch ETL, we use Informatica, DataStage, etc. If you want to do real-time data integration, we use Golden Gate, SharePlex, etc. For ODS, we typically use Oracle or MySQL or any other relational database. For EDW or MPP, we use data warehouse appliances such as Teradata, Greenplum. And for BI, we use Cognos, Business Objects, etc. So these are the technologies which we typically use for the data integration. Now let us understand the challenges. Okay, almost all operational systems are using relational databases, RDBMSs like Oracle. RDBMS are originally designed for operational and transactional based systems. So for the checkout application, which I have explained earlier, taking Amazon as use case or retail platform as use case, you cannot use any other database, other type of database than RDBMS. You have to use RDBMS. But for recommendation engine, RDBMS need not be a proper candidate. Okay, but still people used to use RDBMS itself even for recommendation engine. Not anymore, but earlier they used to use. Now people are migrating to other databases. Earlier they used to use RDBMS like Oracle, even for recommendation engine, which have certain drawbacks, such as not linearly scalable. They are not linearly scalable because RDBMSs are built with overhead to support the transactions and data integrity. When I say data integrity, when you create a table in RDBMS, you give the table name, you give the column names, you give the data type, which means that if you are trying to insert the data into the table, into those columns, it has to match with the data type. Otherwise, you will not be able to insert the data. That means it is doing certain checks while loading the data into the table. On top of that, we also have check constraints. We check whether the column is a not null column or nullable column. We define it as a unique. We define it as primary key. We create indexes for several purposes. All these things have to be taken care when a single record is inserted into a table. Index has to be updated. Check constraint has to be validated. Primary key or foreign key constraints have to be validated. So there are many things it has to do internally before inserting a single record into table. For transactional based systems, it is mandatory. We have to do that. But for recommendation engines, no, it is not mandatory. So if you try to use the RDBMS for recommendation engines, and if it has to scale up, then because of these transactions and data integrity overhead, they cannot scale. So that is one challenge which we see with RDBMS. And then it is expensive. So if you are familiar with costing of any of the technologies which I have explained earlier, such as Oracle or Teradata or Informatica, DataStage, which are ETL tools, they all charge you based on CPU or core. Okay, You have to pay for the software, you have to pay for the support. It's very expensive, and you have to set up all those things in the all these things in the very high-end hardware. Okay. Yeah. Yes. Go ahead. If you have any question, you can ask. Someone have pinged me Papia name. I'm not sure whether I have pronounced it correctly or not. So you might feel that the information is a little bit overwhelming, but you need to understand to actually get the context around the big data. Okay. You can ask question anytime, but make sure you change it to everyone and ask the question, so that even if I do not repeat, people have the context of what I'm talking about. Okay. It is expensive, and there is a predefined schema. The way I have explained earlier, you have column names, data types, and you have to satisfy the schema while inserting or updating the data into the table. Okay, and then data processing do not happen where data is stored, no data locality, which means that when you actually build an application in traditional databases, the storage is network mounted, and as the storage is network mounted, applications tend to do network IO, and as they do network IO and get the data into CPU and memory through using network IO, some filtering happens at the database server level. Nothing happens at storage level. Storage level is only to do the IO. Okay, all the processing, either it happens at database level or application level or client or browser level, but nothing at storage level. This is one of the major issue for the lack of scalability. Okay, and big data, or most of the big data tools, try to address this issue of data locality. We will understand those details a little bit later. And almost all data warehouse appliances are expensive and not very flexible for customer analytics and recommendation engines. Okay, even though data warehouse appliances come handy for reporting purposes or decision support systems, they are not very flexible for customer analytics and recommendation engines. Now we will talk about evolution of databases. We have many choices of databases. Here, I'm not talking about Oracle versus MySQL or versus Informix versus etc. What I'm talking about is RDBMS versus NoSQL versus other types of databases. Okay, we have many choices of databases. One is relational databases, Oracle, Informix, Sybase, MySQL, etc. So let me take this question. I can't answer that question at this time. You have to wait until the end, where I discuss about the jobs in big data. Then I will answer this question. If I could not, if I could not remember this question till that point, please ask the question again, and I will answer this. And also make sure you send to everyone. Send to everyone, and then ask the question, so that others also have the context about what is going on, because they cannot see this chat window, see the chat window, whatever you are asking. So don't ask me privately. I prefer you to ask to public, and then I will be able to answer that question. But this is a little bit out of context for now. We will see that at the end of the session. So we have relational databases, Oracle, Informix, Sybase, MySQL are categorized under relational databases. And then we have data warehouse and MPP appliances, such as Teradata, Greenplum, etc. We have NoSQL databases such as Cassandra, HBase, MongoDB, etc. We have in-memory databases, Jumpfire, Coherence, etc. We have search-based databases, and we have batch processing frameworks, MapReduce, Spark, etc., and graph databases. So you will understand a few of these databases, how they can be leveraged to implement use cases such as customer analytics and recommendation engines as we get into the further topics. Okay. Now we will be slowly getting into the big data. Modern applications need to be polyglot, which means that if you are an application developer, if you are a Java developer, or if you are a application developer using any other programming language like Java, you should visualize big data is nothing but having choice of many other databases, and you should, as you should have knowledge towards say RDBMS to build your application. As an application developer, you should have knowledge about tapping into databases and build applications around it. I will give you a very good example so that you understand. LinkedIn is an example. I will get into the details also a little bit later. Okay, but people tend to confuse and they look at data engineer profile and they tend to get into that role, and then they tend to dissatisfied because data engineer, you will not build the applications, you will actually process the data under the hood, whereas application developers are the ones who actually build the applications. So if you are a passionate application developer, don't focus on data engineer, rather understand all these different types of databases and work towards gaining the knowledge where you can use these databases to build your applications. If you are a data engineer, and your thought process should be a little bit different. We will get to see all those details later. Okay, big data ecosystem history. So now we are getting into the big data. First, we will see the history. It started with Google search engine. Google's use case is different from enterprises of the time. Okay, so the enterprises are primarily focusing on their business use cases, whereas Google felt that internet will be a very big thing. Hence, what they have done, they started crawling the web pages and index based on keywords and return search results. That is their use case. Okay. As conventional database technologies does not scale, they implemented, it should be there, not them. I will correct that. So Google have implemented GFS, distributed file system. So the crawling code crawl the web pages and they store the information in the distributed file system. And then we have Google MapReduce, which is distributed processing engine. And then we have Google Bigtable, which is distributed indexed table. Okay. So I will answer that question, Abhishek, in a moment. Let me finish this slide and then I will answer that question. So what GFS is used for? You Google crawlers crawl the web pages and dump the data into GFS and also into other database also wherever it is relevant. But for the data which is dumped into GFS, which is a distributed file system, they have to process the data as quickly as possible. They process petabytes of data on daily basis. Okay, what the processing is all about? You have to, based on certain keyword, you have to get the relevant search results to the users based on page ranking and many other things, right? So those rules needs to be applied on batch. On huge data sets, they have to apply these rules. Once the rules are applied and process the data, transformations are done, then they have to store the data in such a way that the results can be retrieved as quickly as possible. So MapReduce is used to process the data, and whatever the output of that MapReduce, Google MapReduce is typically stored in something called Google Bigtable, which is nothing but a distributed indexed table. So based upon the keyword, you will have all the values as a value, and then as you type the keyword, because it is indexed, it will they started suggesting you, and then it actually fetches the results. So how that happens? So so the backend engineers, the backend data engineers process the data using MapReduce and store the data in the indexed table, and then the application developers using Ajax and all those things, JavaScript, Ajax or PHP, whatever technologies they are using, they get the results for you. Application developers are the ones who actually developed the search engine based on the data processed and stored by the backend data engineers. Okay, so these two are two completely different roles and request different types of skills. So Abhishek is asking, is processing framework also considered as a type of database? You will understand that by the time we end the session. But to answer your question, each and every database have a processing engine. Okay, so when you issue SQL, based on that SQL, data has to be processed even in RDBMS. So the processing engine is there even in traditional RDBMSs. Similarly, you can so the advantage of big data tools are you can consider it as a database, you can consider it as an API for your programming language. Okay, whereas in traditional RDBMS, it is not possible. Okay, you have to treat it as database only. Whereas in big data ecosystem tools, you directly use APIs and do whatever you want, or you can also use it as a database. I will tell you a classic example. You can store the data in Hadoop, and then you can actually use your visualization tools such as Tableau, connect to the data in big data or Hadoop using um, ODBC connectors. So you have to expose your Hadoop big data cluster as a database to Tableau so that you can actually build reports around it. For tools like Tableau, you can use it as a database. For other purposes, you can directly talk to the APIs, underlying APIs, and you can do whatever you want on top of that data. So IoT is a little bit out of context. I might not be able to cover IoT in this session. Probably I will try to build the content around it and provide a session later. Okay, and let's talk about big data ecosystem myths, which is very, very important. A lot of people think that big data is Hadoop, but it's not the case. Big data is just a concept. It has three characteristics: volume, variety, and velocity. Volume means you have tons of data. Variety means you have all types of data, images, videos, etc., structured, unstructured, etc. And then velocity. Velocity means the pace at which you have to process the data. So big data is Hadoop is a myth. It has many other things, but Hadoop is the major portion of it, but it is losing relevance. Hadoop is getting less relevant in the big data ecosystem, and there are n number of technologies which you need to explore, and I will explain that in a moment. So big data is not a Hadoop. People, if someone says big data is Hadoop, then they are under a myth. And then big data ecosystem can only solve problems with very large data sets. This is another myth. I have been working in big data for past 4 years. A lot of enterprises are trying to use big data because it's open source to minimize their enterprise data warehouse costs. For example, Teradata, if you have to if you buy a rack from Teradata or appliance from Teradata, the cost per terabyte of data is $125,000 3 years back for each terabyte. So if you have 10 terabytes of data, you end up spending 1.25 millions for the Teradata itself. Okay, to support to buy and get the support from the Teradata company. Whereas big data, it's only $15,000, even if you go for a high-end hardware. If you go for commodity hardware, it is even cheaper. Okay, so big data ecosystem can only solve problems with very large data sets is a myth. People are focusing on even to migrate the conventional enterprise data warehouse applications into big data. I have seen n number of use cases where they have moderate success. They don't have complete success. I will explain why a little bit later. But people are interested in moving into the big data ecosystem to cut down the costs on the traditional enterprise data warehouses also. And then big data is cheap. It's a big myth. Big data is not cheap, especially for the enterprises. If you follow the industry for past 10 years, a lot of enterprises have spent tons of money in standardizing their hardware. In that process, they have gone with network storage. They have gone with fiber optics networks, and they have gone with enterprise servers, which are IBM P series servers or or HP supercomputers or Solaris supercomputers, they spend millions of dollars in that. They not only spent on hardware, they also built new data centers to support that, because the requirements for enterprise scale hardware to build a data center is significantly different from commodity hardware. For example, if you understand the architecture of Google data center or Facebook data center, and then a major retail store or major bank data centers, the infrastructure itself is significantly different. Now, if enterprises have to embrace big data, one of the challenges, they have to re-engineer their data centers, and then they have to set up the hardware, commodity hardware, and then they have to introduce the applications into it. That is that is where there is a lot of friction from the enterprises. They accept that big data solves a lot of their problems, but they don't want to get into that because it is not cheap. But people are working around it. We will have solutions to convince the enterprises. But as of today, even today, big data is not very cheap. On top of that hardware hardware, from the learning perspective, big data has a steep learning curve, and enterprises typically compare with the current state scenario while introducing the big data, especially due to the sales guys who don't have strong knowledge about big data. When they go to the enterprises, when the executive management task, as of today, I am able to get a report within 3 weeks. If I give a requirement to my BI team or EW team, I'm able to get a report in 3 weeks or 2 months, depending upon the complexity. If I have to use big data with your company, being as an implementer, how long it will take? These are the typical questions where executive management asks the sales guys. Sales guys try to act smart, and they say, okay, if it takes three weeks to 2 months to get your report with big data, it will, because it's a new technology, it will take another 2 to 3 weeks more, and we will be able to get the report out of it, which is absurd. It will not work that way. You are trying to compare the current state scenario of the company, which is 3 year or which have 3 year or 4 year history, with a new technology. Okay, if we have to even generate a simple report, which it takes 3 weeks for a company, if you have to use big data, it might take few months, 6 months to even 1 year, depending upon the complexities in the organization. Okay, so big data is not cheap, and people tend to compare with the current state scenario and make the decision that, okay, we should not go with big data. We have to convince them that over time it will be as your current scenario, but initially it will take some effort and money to come to that level. Okay, so here there is a question from Gopinath. So everyone, please ask the question to everyone, so that even if I don't repeat, people have context. Can Hadoop replace RDBMS? I heard for transactional databases, RDBMS are far better. Yes, if you, I'm not sure whether you, when you join, if you join just now, yeah, you might have not gone through this slide. So we have many choices of databases. We have relational databases, data warehouses, NoSQL database, in-memory database, search-based databases, batch processing frameworks, etc. So yeah, for the specific transactional use cases, we have to use RDBMS only. We cannot go with Hadoop. Okay, and I will take a use case and I will explain how the polyglot. I have used a term called polyglot in the beginning of the session. A polyglot means modern yeah, even this slide have that. Modern applications, different modules use different category of databases. I will take an example and I will explain for websites like LinkedIn, how we can decide which type of database should be used for which module or which microservice. Okay, we'll get to see that. So big data provide variety of tools and can solve problems quickly. Big data, this is another myth. Big data does not provide any tools. It is just a concept. But there are many technologies which are categorized under big data. There is nothing like big data as a technology. Big data is just concept. Okay, and another myth is big data is data science. Data science is different, big data is different. If you want to do data science on smaller data set, you can use Python or R or any other programming language which have the statistics algorithms implemented. But if you want to use, if you want to implement data science on a very large data set, then you can use some of the big data components. Okay, but big data is different, data science is different. The technologies which comes under big data can solve some of the data science problems at scale. Okay, but the algorithm has to be developed in some cases. Some cases there are algorithms already available. And as of today, only handful of use cases related to data science are being implemented in big data. Most of them are being implemented using R or Python. Okay, and when it comes to data science, data scientists need to have specialized mathematical skills. He has to have domain knowledge. He has to have minimal technology orientation. So he should understand when to use big data, when not to use big data. But at the same time, he need not be an expert in big data. Okay, data science in itself is a separate domain. If required, big data technologies can be used. Okay, so this is another myth. People tend to think big data is data science. Often people have unrealistic expectations on big data technologies. So people has to understand what it is, and then they have to be realistic. So what are the characteristics of big data? On top of velocity, variety, and volume, you need to understand that all the big data ecosystem have some technology characteristics, similar characteristics with respect to technology. So all the technologies which are categorized under big data ecosystem typically use distributed storage. Okay, and fault tolerance is taken care by something called replication. In traditional technologies, they use RAID, but in big data, we hardly use RAID. Instead, we use something called replication, which is similar to mirroring. And then for distributed computing, and it has distributed computing or processing, and it uses data locality where code goes to data. I will not get into too many details here. When it comes to traditional databases, data comes to code, whereas in big data, code goes to data. I will not cover at this point. If you want, you can actually look into my other videos in my YouTube channel, and you get the meaning of data locality, or you can Google it and you will understand. Scalability. So almost linear, you can achieve almost linear scalability using big data ecosystem. It runs on low-cost hardware, often commodity hardware, but now they are also working on means the vendors such as Cloudera, Hortonworks, etc. are trying to make it work on enterprise hardware also, so that they can convince the enterprise clients to use the enterprise hardware itself to solve their some of the problems. Low licensing costs, and here the caveat is low cost hardware and software does not mean that big data is cheap for enterprises, for the same reasons which I have explained earlier. Okay, big data ecosystem of tools can be categorized into distributed file systems, which are HDFS, cloud storage, distributed processing engines, MapReduce, Spark, distributed databases. Distributed databases can be used for operational use cases. NoSQL, HBase, Cassandra, MongoDB falls under NoSQL databases, and such-based databases such as Elasticsearch are distributed databases. They are nothing but distributed indexed tables or distributed indexes. Okay, Elasticsearch is a distributed index. HBase and Cassandra are distributed indexed tables. And now we will understand the evolution. After successfully building search engine in new technologies, Google have published white papers on distributed file system, which is GFS, distributed processing engine, which is MapReduce, and distributed database, which is Bigtable. Okay, distributed database is nothing but Bigtable is nothing but a distributed indexed tables. That is the concept behind Bigtable. So using these white papers, development of big data technologies have started. GFS and MapReduce white paper is translated into Hadoop. using Java as programming language. And Bigtable is translated into Cassandra, MongoDB, HBase, etc. So there are many technologies in distributed databases. And now when it comes to data storage options in big data ecosystems, we have distributed file systems, HDFS and cloud storage, distributed databases, Cassandra, HBase, MongoDB, Solr. So you can have your data in either in distributed file systems or distributed databases. So distributed file systems are primarily for streaming and batch access. Distributed databases are for random access, which are typically distributed indexes or distributed indexed tables. Here the buzzword is distributed. You need to understand the relevance of distributed. Data ingestion. So we have distributed file systems, we have distributed databases, but somehow we have to get data into this. So that's where the data ingestion comes into picture. Data ingestion is nothing but getting data into your big data system or any downstream system. In traditional EDW, we call it as ETL, and ETL is the data ingestion strategy in traditional EDW. Here, data ingestion strategies are defined by sources from which data is pulled and sinks where data is stored. So the data ingestion strategies can differ significantly. We might use ETL, we might not use ETL. Okay, sometimes the terms are a little bit different here. So sources are typically relational databases, non-relational databases, streaming web logs, flat files. Okay, these are the typical sources, and the sinks are HDFS. It could be, again, you can push data to a relational or non-relational databases, and then you can also have to push data into data processing frameworks such as Spark, MapReduce, etc. So these are sinks. Okay. Scoop is used to get data from relational databases. So if you have to ingest data from RDBMSs into the big data technologies, Scoop is one good technology. It can connect to the source databases using JDBC and load into data into the target systems. And then Flume or Kafka is used to read data from weblogs. So if you want to get data from weblogs and store into big data tools or big data technologies, you can use Flume and/or Kafka. In some cases, we use Flume and Kafka in tandem. In some cases, we use only Flume. In some cases, we use only Kafka to get data from weblogs and then store into downstream applications. So while storing into sink, if you have to do some processing, so at times, I will give you a use case later, then you will understand. At times, there could be a scenario where you want to process data a little bit by applying certain rules on each and every micro batch, which is built by Flume or Kafka. Flume or Kafka does not store one record at a time in sync. It will pull all the records into a file based on certain thresholds, and then it will take an action to store that file into underlying sync. It could be HDFS or it could be anything. Some cases, whatever data that is accumulated in a queue or in a file has to be processed or transformed to do streaming analytics. That's where the Spark streaming, Storm, Flink, etc. Comes into picture. Okay, so there is a question from Sunil. Again, please ask by marking as everyone. The question from Sunil is, can we not use traditional ETL tools to load data? That's what I'm trying to say. There are different use cases for which you have to use different types of technologies. And I will explain what are the challenges of using traditional ETL tools when it comes to big data in a moment. There are a few slides on that. And then data processing, if you want to do in batch, you have to use IO based. You can either use MapReduce, which is IO based technology, and then there are other technologies on top of MapReduce, Hive, Pig, or wrappers on top of MapReduce. Instead of writing complex MapReduce code, you can use Hive or Pig, Hive queries or Pig scripts to process the data. But bottom line is, all these are IO based batch processing technologies. And then we have in-memory technologies such as Spark. And Spark data frames is a wrapper on top of core Spark where you can access data using SQL type of syntax. So if you have to do the data processing in batch, either you have to choose MapReduce, which is IO based, or Spark, which is in memory. As part of the data processing, typically we focus on transformations such as aggregations, joins, sorting, ranking, etc. So in big data, most of the ETL has to be done either by using MapReduce or by using Spark, either by using IO-based distributed processing engine or in-memory distributed processing engine. You should not use traditional ETL tools because traditional ETL tools themselves have the servers, and if you start using their servers to process the data, then the performance cannot scale. For that reason, we tend to use big data technologies itself to process the data. But traditional ETL tools also have the big data connectors. There is a caveat associated with it. I will explain it later. Okay, so you should actually focus on these technologies rather than the tools. And along with those technologies, you need to understand the programming languages also. So now comes to data processing operational. Data is typically stored in distributed databases, supports CRUD operations. CRUD stands for create, read, update, and delete, which is nothing but insert, update, and select queries. Data is typically distributed and indexed by key. Fast and scalable random reads. Examples are HBase, Cassandra, MongoDB, NoSQL. In search, it is Elasticsearch. And if you have to build applications around it, you have to use your traditional programming language. Treat these things as alternate database to RDBMS, and you have to understand ORMs associated with it, object relational mapping, or whatever terminology they use. So, for example, if you are JavaScript guy, if you are familiar with mean stack, MongoDB, Express, Angular, and Node, in that we use something called Mongoose. Mongoose is a ORM framework for MongoDB. So as an application developer, you have to focus in those areas and try to understand which use cases can be implemented using these distributed indexed tables, and you have to use those things as part of your application development process using your traditional programming language. Like any database, you can also do insert, update, select, and you have to build an application around it. Okay, data analysis or visualization. Processed data is analyzed or visualized using BI tools, custom visualization frameworks such as D3JS, ad hoc querying tools. So all these things can be accomplished using data analysis or visualization. In this area, big data does not have many alternatives. At times, either you have to use traditional BI tools or you have to use your application programming languages itself and application programming frameworks, and you have to build applications around it. So there is a question from Parag. Can we read data real time from RDBMS? Yes, we can, and we are getting into that. I will explain that in detail. So let us recollect how data integration is typically done in enterprise. So again, we are going into the same diagram which I have explained earlier. We have different sources. We have ODS. We have target systems such as EW. And then we have data integration layer, ETL or real time. Okay. So from OLTP, we can get data in real time, or we can use ETL tools. For real time, we can use tools like Golden Gate, Shareplex, etc., where it reads actually the redo logs or commit logs of the RDBMS databases, and then you can integrate to downstream systems. So we can read data real time from RDBMS using tools like Golden Gate and Shareplex. So once we get data from source systems through data integration layer into ODS or target system using performing ETL, we can actually visualize the data using the reporting technologies, BI technologies. Okay, so enterprise data warehouse is built for enterprise reporting for selected audience in executive management. This is the key. So enterprise data warehouse is being used only by handful of users. And for data integration, we will have operational data store as well as enterprise data warehouse. When it comes to ODS, sources are disparate. There are different types of sources: RDBMS, mainframes, external applications, weblogs, etc. We use to get data in real time from databases. We use tools like Golden Gate Shareclex. For batch, we use tools or custom tools, in the sense we might use Informatica. We might use our custom tools also, because to get data into ODS, you don't require a lot of transformations. You just copy data as is in most of the cases. And for that, we typically build our own custom tools. And then uses of ODS is compliance, data lineage, reports, etc. When it comes to enterprise data warehouse, sources could be ODS or other sources. But for most of the actual reports which are published on regular basis, meeting certain SLAs, we typically source data from ODS only. And then ETL, either we use tools or we can use custom also. Tools are Informatica, Ab Initio, Talend are the most popular ETL tools. DataStage, etc. are the most popular ETL tools. For reporting or visualization, we use ODS, enterprise data warehouse, and then tools. So we connect our reporting tools to enterprise data warehouse or ODS and generate reports out of it. Okay. Now we will see how data integration can be done using big data ecosystem. So what is the challenge with this? You cannot implement customer analytics or recommendation engines using this architecture. Okay. You have to look for an alternative. Now we will see how the data integration can be done using big data ecosystem. For that, if we have to get data from RDBMS, we use Scoop. If we have to get data from streaming logs, we use Flume or Kafka. And then if some processing need to be done before loading to databases or HDFS, data is processed through streaming technologies such as Flink, Storm, etc. And there are two engines to apply transformation rules at scale. One is MapReduce and other one is Spark. Okay. We will see disadvantage of MapReduce and why Spark with new programming languages such as Scala and Python is gaining momentum. So first, let us understand the disadvantages of MapReduce. MapReduce works very well for use cases like Google, where we get gigabytes of data, terabytes of data processed at scale. It works well. And Google, Facebook, all these are technology companies, and they can hire top-notch developers, and they can implement whatever they want using the programming itself. Instead of focusing on the tools, they use open source programming languages, and they build their own applications, which is not practical for enterprise clients. Enterprise clients cannot hire those high top-notch programmers, and hence they fall back on tools. So when it comes to MapReduce, there are certain disadvantages when tools are being deployed on top of MapReduce. Because MapReduce is designed for batch, it is not meant for interactive and ad hoc reporting. So if I use Tableau to connect to data in Hadoop using MapReduce-based solutions such as Hive connector, even if I try to generate a report on 10 records, it will take a minute. And whenever you refresh, it will take another minute, which is which is not user-friendly. Hence, we cannot use the MapReduce-based solutions such as Hive to connect via visualization tools such as Tableau. MapReduce is typically IO bound, and processing of micro batches can be issue. Okay, because it is IO bound, micro batches cannot be processed very quickly. Hence, we tend to look for alternatives, and we will look into the. I will explain the alternative in a moment, how this can be addressed. And then one major disadvantage when it comes to MapReduce based solutions in enterprises is it has too many tools or technologies to build applications. You need to understand MapReduce, you need to understand Hive, you need to understand Pig, you need to understand Scoop, you need to understand Flume, and then you need to use programming language like Java, and you need to understand workflow technologies like Oozie. And if you have to, each one of these has different syntax and semantics, and your implementation timelines will explode. Okay, hence enterprises push back on Hadoop earlier. And another disadvantage is, which I have explained already, not suitable for enterprise hardware where storage is typically network mounted. Okay, there is one question. Okay, the question is from Vamshi. Hive jobs through JDBC connection creates MapReduce jobs, right? Yes, that is correct. And that's why it is very slow. And then comes Spark. Spark can work with any file system, including HDFS. Processing is done in memory, hence IO is minimized. It is suitable for ad hoc or interactive reporting. It uses Spark engine to support the queries submitted by the BI tools such as Tableau. Unlike Hive, Spark uses Spark engine uses Spark, and it uses memory. Hence, it is faster. Streaming jobs can be done much faster than MapReduce because it does in memory. Applications can be developed using Scala, Python, or Java, etc. So you just have to focus one programming language, and then if you have to get data from source database on regular basis as part of your application, you can directly use JDBC, and then you can create something called RDD, and then you can process the data. So data integration can be done using Scala or Python. You choose one programming language and you can achieve everything. You can connect to the source database and get the data on regular basis. You can stream data using Spark streaming. You can leverage data frames and SQL embedded in programming language. Unlike Hive, where it only provides SQL interface, you have to use another programming language or scripting language to write a wrapper around it. Whereas here, the Scala, we will use the programming language as the main driver, and if we have to run a Hive query or SQL, you can create a Hive query or SQL and using data frames, and you can embed in programming language, and you can do further processing. You have the flexibility of either using SQL or using the Spark APIs, or both. You can also do whatever processing can be done with SQL, and then create RDD out of it, and then process using Spark APIs. So it gives a lot more flexibility. You don't need to use different type of language for different purposes. Scoop for getting data from source database, which have its own syntax and semantics. And then Hive to build the queries, or Pig to process the data, and then embed in a programming language, the scripting language, and use Uzi for scheduling, etc. You don't need to worry about all these things. You have very few moving parts when you try to implement your applications using Spark. That's where Spark is getting a lot of traction, not only from the performance perspective, even from the implementation. Using Spark can be much more effective and more predictable because you have fewer technologies to explore. Now comes how we can use all these things in a picture. So Abhishek is asking the question, what is the maximum memory which can be cached while using Spark API? It depends upon your cluster. If your cluster is capable of whatever capacity, you can store that much. And you have to understand the nuances of it, and you have to make sure how to use it effectively. Okay. So this is how the data integration is done. Is done in a big data ecosystem. You have source systems, you have a big data cluster. Now you can see that we have one uniform cluster. Earlier we have ODS, which runs on Oracle and MySQL, which requires different types of hardware. You have EDW, which is Teradata appliance or Greenplum appliance, which requires a different type of hardware. And then you have ETL tools such as Informatica Data Stage, which requires a different type of hardware. Over time, the maintenance can be a nightmare, and you will end up spending millions of dollars for maintenance those disparate hardware. Here, you have a uniform hardware. You have same set of nodes, which will be taking care, which will take care the ODS, which will take care of EDW, which will also take care of ETL. For real time, if you want to get data in real time from OLTP by using Golden Gate, you have to set up a Golden Gate for it. You have to get the data, and then you have to integrate with your target systems using Kafka or some other data integration framework, or JMS queues. Typically, people use JMS queues to get data from Golden Gate and then push into JMS queue and then store in the HDFS. So the question is, the question from Prakash, is Spark using distributed memory? Spark uses memory. Okay, Spark is a cluster. There are multiple nodes in a cluster, and each one will have memory. And it uses something called RDD, which is nothing but a distributed in-memory collection. Okay, and then Spark have APIs to process data on top of it. This question is not correct. Is Spark using distributed memory? Yeah, it uses distributed memory. That is correct. But how it uses is, you need to understand to a concept called RDD, a resilient distributed dataset, where it will create a in-memory distributed collection, and then Spark provide APIs such as MapReduce, many other APIs to process your data the way you want. Okay, so coming back to this picture, there could be a reporting database, a small lightweight reporting database, because already enterprises have spent a lot of money on enterprise BI tools. Even though Spark works for most of the cases, in some cases Spark might not be as effective as a traditional RDBMS for reporting. Hence, in some cases, we use lightweight reporting database, and then we generate reports out of it. Okay, so this is how it looks like when you try to implement using big data ecosystem. So there is one question from Chandrasekhar. The question is, when you say no ETL, does that mean it can only process transactional data? Yes. So typically we don't do. So if you again go back to the previous picture, when it comes to ODS, typically we get data from sources into ODS in real time or even in batches without doing much ETL. Same thing applies here. So when we typically get data from real time, we don't do a lot of ETL. We just get data in real time or batches and store into ODS. ETL happens within Hadoop itself or big data itself from ODS into EDW. ODS and EDW are nothing but logical databases on big data ecosystem. Okay, so the actual ETL happens only here. The heavyweight ETL happens only here. Hardly any ETL happens. Means hardly any complex transformations happens when we actually pull data from source systems into this. Okay, so now I will talk about the big data technologies. At the bottom, we have the core components, which is a distributed file system. And then we have MapReduce and non-MapReduce based technologies. We have Hadoop ecosystem, such as Hive, Woozy, Pig, Mahout, Scoop, etc. Each one is specialized on one particular area. Scoop is to get data from source database into Hadoop. Hive is to run SQL queries to process data in Hadoop. Pig is alternative to Hive in some cases. In some cases, Pig is a little bit flexible than Hive. Mahout is for machine learning in Hadoop. And then ad hoc querying tools, we have Impala or Presto. They are only capable of querying data from Hadoop. You don't do it for heavyweight processing. You don't use Impala or Presto for heavyweight processing. For NoSQL, we have HBase Cassandra. For in-memory processing, we have Spark. Okay, so here These are MapReduce based technologies. These are non-MapReduce based technologies, which give a lot more flexibility than using just MapReduce. You can do ad hoc querying. You can use NoSQL databases for operational use cases such as recommendation engines. You can use in-memory process. You can use Spark for in-memory processing under non-MapReduce. And then data ingestion. We use Kafka and Flume to get data from the source systems. If we have to process before loading into the target, we use technologies such as Storm, Flink, etc. And they tend to directly store data into distributed file system. Once the data is in distributed file system, we will process the data using either MapReduce or non-MapReduce based tools. Now I will take the use case of LinkedIn, and I will explain how all these technologies work together. So there is a question from Papia. How can I optimize my database, particularly my configuration file, for periodic reads that occur together in short bursts at the sacrifice of the speed of inserts, updates, and deletes? For periodic reads, let me understand this question. I don't understand this question. You need to basically get into the nuances of big data, and then if it is related to big data, then only you can actually phrase the question in a more effective manner. I could not understand this question. Okay. Anyway, let me explain the use case of LinkedIn, and let me explain what is polyglot and what are different databases that can be used for a platform or application like LinkedIn. So this is the LinkedIn homepage. Okay. Here, if you want to be a premium customer, you can become a premium customer by clicking on this, or you can also go for business services. When you try to enroll for these business services or premium customer, or try to be a premium customer, it has to store that information in RDBMS. It's a transaction that is happening between you and LinkedIn. Okay. As it is a transaction, we have to use RDBMS. There is no other alternative. Either Oracle or Informix or MySQL, whatever RDBMS you want to use, you can use. And then there are other modules in LinkedIn. The main thing is profile. Okay. And if you look into the profile in the LinkedIn website, let me close this one. So there are several things. First one is summary, and then your experience, and then you have the projects, endorsements, and many other things, your qualifications and all those things, certifications, etc. So profile is nothing but a rich text, a large text. Means profile can be few thousand words. So it might fit in there could be some very good content management database, and you can store your profile in that. And then when it comes to the endorsements, it is a very good candidate for NoSQL. Okay, you can use NoSQL type of databases for endorsements. You have to be a little bit patient. Okay, so the question is it necessary to have an expertise in programming language like Python or Go, Java for entering into big data field? I will ask that question in a moment. Okay, Shashank? Okay, let me take the Papia's question related with write once, read many. I mean to say how it works in Hadoop. That's where the NoSQL comes into picture. Once the data is indexed, for example, in this case, I have the endorsements. Okay, over a period of last 5 years, let's say I have 5,000 endorsements. Hardly I will get 1 or 2 endorsements on a weekly basis. Okay, so it's kind of it's a classic example of write once and read many times. When I go to the profile, I don't read the raw data. I have to read the pre-processed data to to display the endorsements. So this is nothing but the report. This is nothing but a customer analytics. I am getting insights about how my endorsements are. Okay, hence we can name it as endorsement engine, similar to recommendation engine. So you right now around 100 people or 50 people might be listening to me, and let's say they are all they endorsed me on different technologies. Even if I don't see immediately, or if people who are looking at my profile don't see immediately, that is fine. There is no harm with it. But over time, I need to get the report, right? So the action of endorsement is a real-time action. When people endorse, they should get the feedback immediately that they have endorsed someone. Okay, the job is done at that time. You endorse someone, it acknowledges that endorsement is done. And then when the other users go to the profile, okay, here we use the NoSQL. The key is my username, and the value is my endorsements at a raw level or at the aggregated level. For you, when you try to endorse, it will go to the raw level table. On top of that, the data also will be logged into weblogs, and those weblogs will be ported at regular intervals by technologies like Kafka. Kafka poll the data and try to understand what all technologies are being endorsed for all the users, and try to update this aggregated table at a very regular interval. It could be a minute, it could be 2 minutes, it could be 5 minutes. It depends upon the SLAs LinkedIn defines. Hence, when the endorsement happens, data will be persisted in a in raw format in one of the table, and also streamed to weblogs, and then aggregated and stored in another table which is already aggregated. So the performance will be much better when people try to read the report by going to my profile later, after the endorsements are done, or even when the endorsements are being done. Whoever try to access my to see the report of my endorsements, they see from a different table. So this is how we actually, here there are two things. One is operations in real time, both read and write, and then streaming analytics are the two primary use cases which you need to keep in mind as an application developer. If you're an application developer, if you want to understand where NoSQL databases can be used, these are the type of use cases where NoSQL can be used. And where Hadoop or MapReduce or Spark comes into picture. So there is jobs here. Okay, I go to jobs. Based on profile, it will recommend some jobs. You can see it is most of the top jobs that are recommended are big data jobs. So they LinkedIn go through my profile and see what my experience is, and it will recommend the relevant jobs for me. On top of that, let's say you started applying for the jobs. So your profile might be different and your interest might be different. So the recommendation can be at different level. One is based on your profile, best match to your profile. Second one is based on your interest. So based on your traffic, your activity on the while applying the jobs on the website, based on your traffic, they have to capture this information and they have to process using so over time, for all the users, the amount of data can be pretty huge. If the data is pretty huge, they have to process using batch processing frameworks such as MapReduce or Spark, and store the data again in some NoSQL database such as DynamoDB or MongoDB or Cassandra, and then over time you will get recommendations more appropriately. Okay, so that's how it works. So for recommendation engine, for the backend processing, you can use tools like MapReduce or Spark, tools based on MapReduce or Spark. But to display the recommendation engines, you have to again use your programming language, connect to underlying database, typically a NoSQL database or such based databases, and you can build reporting on top of it, or recommendation engines on top of it. So this LinkedIn as a whole is one application which is divided into several microservices. One microservice which is becoming a premium customer is implemented using a traditional RDBMS. Profile can be implemented using a different different type of database. Endorsements can be implemented using NoSQL. Recommendation engines are supported by both NoSQL as well as MapReduce basic tools, and hence, as each microservice requires a different type of database, this is called as polyglot application. Polyglot means each module or each microservice within an application might be pointing to different type of database depending upon the use case. You need to understand the use case, and you have to define the you have to determine which database should be used, and you have to use your application programming frameworks on top of it to build the application. So LinkedIn is a classic example of using all the technologies to build. Here, emphasis should not be on big data. For application developers, emphasis should not be on the big data. Emphasis should be on the several options which are available as of today and how they can be leveraged to build their applications. For data engineers, yes, they have to be specialized in big data technologies. They have to learn MapReduce, they have to learn Spark, etc. Okay, so there is one relevant question from Shashank. Is it necessary to have an expertise in programming languages like Python, R, Go, Java for entering into big data field? Again, I will come back to that question. When it comes to big data, there are different types of roles, which I will explain, and at that time I will answer this question. What all skills are required for different type of roles? Okay, so let's go to the next slide. So here is another perspective of big data technologies, how they are typically used. Scoop is used for extract and load. Hive is used for transformation and load. Custom MapReduce can be used for ETL if required. Impala for interactive or ad hoc reporting. HBase for real-time data integration or reporting. Spark and all have their relevance. And even you can use, you should have ingestion tools also in this, like the previous slide, but this slide is a little bit outdated. So before getting into the, let's understand what is the role of Apache here. Okay, each of these are separate projects incubated under Apache. HDFS and MapReduce, Hive, Pig, Scoop, HBase, Spark. Most of these are Apache projects. They are open source projects incubated in Apache. So in plain vanilla mode, depending upon the architecture, each tool or technology needs to be manually downloaded, installed, and configured. So these are all nothing but softwares. They are nothing but jar files, a compiled Java code. And this Java code has to be deployed or downloaded and installed on all the nodes in the cluster. And you have to do configuration so that the cluster can work as a unison, as one unit. Okay, and if you have to do it on a very large, so in some of the enterprises you might see 300, 400 nodes or even 1000 node cluster. If you have a 1000 node cluster and if you have to download all the jar files on all the nodes in the cluster, you have to set up on all the nodes in the cluster and apply the configuration changes on all the nodes in the cluster. It is very tedious. Okay, but still people use plain vanilla mode so that they can be very close with the latest versions from Apache directly. But they use DevOps tools such as Puppet or Chef to set up clusters using plain vanilla. Okay, and then disadvantages: installation is tedious. Even if you use Puppet or Chef to set up plain vanilla, the installation is still tedious and error prone, and you need to have solid DevOps engineers to make it happen successfully. You need to integrate with monitoring tools such as Ganglia and Agios to monitor and alert on regular basis to support the cluster. those are the disadvantages. You need to, the installation is tedious, and also you need to integrate with monitoring tools. Now comes Hadoop distributions. Different vendors pre-package Apache suite of big data tools into their distribution to facilitate. Okay, so what does that mean? If you use Cloudera or Hortonworks or MapR, which are three major vendors in Hadoop distributions, they provide an interface where everything will be pre-packaged, and then you have to install on one node. Once you install on one node, you will have a wizard to set up on all the nodes in the cluster. So you just need to give the IP addresses of all the nodes on which you want to set up the big data, and it will take care of installation. And then for configuration, it will provide the web interface, and you just have to update that web interface, and then the deployment will be done on all the nodes in the cluster. So configurations will be deployed automatically on all the nodes in the cluster. So leading cloud distributions include Cloudera, Hortonworks, MapR. AWS also have EMR, Elastic MapReduce, and then we have IBM Big Insights and many more. And this is how it looks like. Apache Foundation have all the technologies in it, and then Cloudera, Hortonworks, MapR, etc. actually bundle all these technologies and provide a uniform package for you to set up easily, to make the setup as easily as possible. Okay. So one question from Raghu. Do we need to focus on data visualization tool as well as part of big data? Again, we'll get back to that. It depends what type of role you want to be. If you want to be application developer, you might not have to. You don't need, but understanding the BA concepts will help. At times you have to implement some of the BA use cases in custom fashion using application programming languages. So you have to understand some of the BA concepts over there. If you are a data engineer, mostly you will spend your time on backend processing, backend data processing. There also you need to have a little bit of knowledge in BI. If you have BI knowledge, it will help a lot to be a liaison between BI team and the backend data processing team. But that doesn't mean that it is mandatory to learn BI tools. But having knowledge will definitely help. So certifications is key to get a break in big data. You might not get a job directly just based on certifications, but it will let you to promote skills. It will demonstrate industry recognized validation for your expertise. You will meet global standards required to ensure compatibility between Spark and Hadoop and other big data technologies. You will stay up to date with the latest advances in big data technologies such as Spark and Hadoop. If you keep on doing certifications once in a while, you will understand what is happening in the industry. No matter how many technologies you know, on job you will be working only on few areas. You might not get your hands dirty on all the relevant areas. But as you want to grow, you need to understand what is happening around. Otherwise, you cannot grow that easily. Certifications is one way to explore the other technologies within a defined scope, and then groom your skills to grow in your career. Okay, and out of all these things, as the information is simply overwhelming, okay, if you start learning directly, if you start learning big data directly, what will happen is you will be pulled in all directions and you will not learn anything after 6 months. But if you focus on certifications, it will have a defined scope and you will understand those technologies in depth to clear the certification. Even if some things are written off and new technology comes into picture in the relevant area, you can easily compare and contrast and you can learn the new technology. So certifications add a lot of value from that context. It will define a scope for you. Even if you don't want to give the certification, if you learn from the certification curriculum, it will define a well-defined scope for you, and it will help you to achieve something within certain period of time. So it will set you a goal in the form of certification, if you focus on certification curriculum and prepare based on that. Otherwise, you will be pulled in all the directions and you will not learn anything. And believe me, this tip of this tip to people to get certified or prepare towards the certification have helped hundreds of people in my career. Okay. Take certifications from only vendors like Cloudera, Hortonworks, Mapper, Databricks, etc. Don't go with companies like Edureka, Simply Learn for certifications. They don't have any value, and also they don't train you from the industry perspective, or there is no well-defined scope to explore these technologies. So don't go for those companies for the certifications. They have zero value in the industry, and also scope is not well defined in most of the trainings. Okay. And you can also look into these two URLs. Let me paste these two things in the chat to get more details about the Hadoop and big data certifications. So these two are the URLs. Let me do it in the Hangout also. So all the questions in live chat I will answer later. If you want to have those questions in interactive fashion, please join my WebEx invite. You can see the link over here. Okay. You can join the WebEx invite and you can ask the questions. Anyway, so now these two are the links. Save these things because the chat will be deleted. Save those links and explore it later. I have all the details related to certifications. And then resources to learn. I have a channel called youtube.com/itversityin. There are 900 plus videos, 100 plus playlists, 6 certification courses in big data. I have a website, itversity.com, which launched recently. A few courses added, other courses will be added over time. Courses will be either role-based or certification-based. And also I'm working on blogging platform for IT content. So anyone of you are interested in blogging, send me an email with blog as subject, and I will send you the note, and you can be a blogger on my website. So now comes the job roles. People might be very curious and they want to know about the job roles. So there are different job roles in big data. One is Hadoop developer. A fresher to a 7 years experience guy can fall in this category. And what he need to learn? He need to learn Hadoop. He need to learn programming using Java or Spark, programming using Java for MapReduce, or programming using Scala or Python or Java for Spark. But Scala and Python are more preferred than Java if you want to get into Spark-based projects. Hive, Pig, Scoop, etc. You have to have multiple skills in this. Even Flume, Kafka, those data ingestion tools also. Hadoop administrator, 0 to 10 years. And you need to understand the distributions, and you also have to be proficient in Linux. So if you want to be admin, this is the first you need to build your skills on Linux. Learn Hadoop administration. I have content on my channel also. If you go to my YouTube, and go to this is my channel homepage. If you scroll down, there is a section called Hadoop administration. So I have covered Hortonworks and Cloudera, both on AWS as well as virtual machines on your PC. So if you have a 16 GB laptop, you can actually start setting up your cluster by following these two playlists, one for Hortonworks, one for Cloudera. For AWS, if you don't have 16 GB laptop, you have to use cloud providers such as AWS, Google Cloud, etc. And you have to look into those playlists. Okay. So Sandeep is asking, could you please send this PPT? yes, I will be sending this PPT, and also all the material is already available in a blog, so you can actually go to this blog and have the reference to you, and the blog also have the PPT. After the video, you can see the PPT here. You can download the PPT directly from here. Okay. And also, if any of you liked the content, please click on share here and share this so that it reaches out to the more and more people. Whatever I have discussed in this video will be part of this link, and then eventually people can use this blog itself for the reference. Okay. Now let's go back to the presentation again. So for big data, another role which is very prominent in big data world is data engineer or big data engineer. For this, you have to have data warehousing skills. You have to learn ETL. You have to learn Hadoop, Spark, Hive, Pig, Scoop, etc. But the primary focus should be on processing your data. You need to understand the data integration framework, CTL, etc., and you should be able to process the data. You also might have to learn data modeling. And then big data solutions architect is a senior role, 12 to 18 years. He does not work on projects on day-to-day basis, but still he need to have hands-on experience, because he has to define the framework, and also he has to make sure whether the developers and other team members are actually following those framework or not, best practices within that framework or not. And also at times when the POCs have to be implemented, big data solutions architect has to lead from the front. He should be able to execute the POC, starting from infrastructure to the little bit of development. And once he decides that for POC, the success criteria is to have an answer. It could be a success, it could be a yes, we can go and implement at a scale, or it could be no. If it is no, the project will be discarded and a new POC has to be executed to evaluate other set of technologies. If it is yes, the framework has to be handed over to development team, and development team will actually build a complete application. So to have that much of knowledge, he has to have deep understanding of big data ecosystem, such as Hadoop, NoSQL, and also he has to have some infrastructure background also. And then there is another role called infrastructure architect. Okay, so people can actually become infrastructure architect. For them, they are primarily Hadoop administrators can become infrastructure architects, and they control end-to-end from the infrastructure perspective. On top of these things, we also have application developer role. For the application developer role, you need to understand what all different databases that are available as of today, and most of them are categorized under big data ecosystem. And application developers should be capable of designing and developing the applications based upon the type of databases they want to use as part of the modules of their applications. Okay. So that is it. And before wrapping up, I will also demonstrate a typical cluster, how it look like. So there is one question from Vamshi. Efficient way to process or handle multiple HDFS file size less than block size. That is out of context. This is just big data introduction. This you are actually diving deep into it. There is a playlist on performance tuning. Okay, and as part of the performance tuning playlist, I have explained a little bit about how to process data efficiently when you have multiple HDFS files less than block size. Okay, if it is MapReduce, you have to use combined file input format, or you have to use Hadoop archive, and then you have to unarchive and process the data using combined file input format. Okay, and Gopinath is asking, can freshers take CCP by preparing from your playlist? I don't recommend CCP. CCP requires some experience, and it is also outdated. I will rather recommend CCA Spark and Hadoop developer as a first certification for anyone, whether it is fresher or experienced. I highly recommend CCA Spark and Hadoop developer because it covers multiple technologies, including Spark. Okay, so let me demonstrate a cluster for you, and let me show you how these technologies will be there in a cluster. Okay, if you already took CCA, if you are a fresher, I will probably recommend you to go for AWS certifications. Okay, it will cover from the cloud perspective. I don't have material on my website, but if you are a fresher, I will, or even for experienced professionals, very highly experienced professionals, if they want to do multiple certifications, I will highly recommend for them to do cloud-based certifications. That will make they will get more options. Even for freshers, I will recommend the same. For intermediate experienced developers, from 3 to 12 years of experience guys, I don't recommend multiple certifications. They can do one certification, such as CCA, and then look for a job. Once you are in a job, you can actually explore the other certifications. There is no point in doing multiple certifications. You don't get much value. Okay. So yeah, yes, Gopi, you can ask that one more question before I get into the cluster. Go ahead, Gopi. Am I planning to cover Elasticsearch? Not immediately, but I have the plan. I am also looking for any person who want to write blogs or create videos out of it. Over time, yes, but not anytime in near future. Okay. Anyway, let's get into the cluster. So this is a typical cluster, and if you look into Cloudera or Hortonworks or Mapper, they don't talk about Hadoop anymore. They call it as big data cluster. They don't even use big data term. For example, Hortonworks provides the distribution with a term called HDP. Okay, HDP stands for Hortonworks Data Platform, and they don't emphasize only Hadoop. It's a data platform. So it comes with NoSQL database such as HBase. It comes with Spark. It will have data ingestion tools, everything in one thing. That's why they are not Hadoop clusters anymore. You can either consider as big data cluster or data cluster. Okay, and Hortonworks call it as Hortonworks data platform, and Cloudera call it as enterprise hub, I guess. Cloudera enterprise. So they don't talk about big data or Hadoop in it. Even though they say making Hadoop fast, easy, and secure, it's not just Hadoop. They come with many other technologies within the same cluster. They should have mentioned making big data fast, easy, and secure rather than making Hadoop fast, easy, and secure. Okay. Now we have many technologies. Core components are HDFS and MapReduce or non-MapReduce. So MapReduce or non-MapReduce run on YARN. Some of the non-MapReduce tools are capable of running on YARN, but MapReduce typically run on YARN. So the core components are these three. Okay, HDFS, MapReduce, and YARN. This is Ambari, which is a web interface to monitor Hortonworks cluster. Okay, if I click on hosts, it will show the size of the cluster. There are 8 nodes in the cluster. Okay, and each nodes have different number of components. Okay, especially if you click on HDFS, you will understand on what all nodes HDFS is configured. It is saying the name node is name node, secondary name node, and then data nodes on all 8 nodes. But typically we don't configure like this. In production cluster, we will have hundreds of nodes. Name node will be running on one node, secondary name node will be running on one node. So in this case, name node is running on 48, Secondary name node is running on 153. This looks good. But data nodes will not be running on the same nodes where the name node and secondary name node is running in typical production cluster. Okay, same is the case with Yarn. We have master, which is resource manager, and we have slaves, node managers. Node managers will be running on the same nodes where the data nodes are running. Okay, so these are the core components. Don't worry if you don't understand these terms. You have to learn big data to understand these terms. I'm just trying to show the cluster. And then we have Hive. Hive is a MapReduce based tool. We have HBase, which is a NoSQL database. We have Pig and Scoop, which are again MapReduce based tools. And then we have Storm, which is a streaming analytics tool. We have Flume, Kafka, which are nothing but data ingestion tools, and Spark. So all the technologies comes as a package within the cluster. So Hadoop administrator will make sure that all these services are up and running all the time, and developers will focus on deploying the applications. Big data engineer closely works on these technologies by processing tons of data, and then application developers use these technologies as database to build applications on top of this data. Okay, so earlier there was one question about, Shashank have asked this question: is it necessary to have an expertise in programming language like Python or Go, Java, etc.? So Go is not used in big data that extensively. R is not again used that extensively. R is primarily a data science tool, a data science programming language. A lot of data science are proficient in R. And if you have to implement in big data, traditionally we used to re-engineer for big data. You have to learn either Python or Scala or Java. You have to know at least two of these three programming languages. Okay, if you want to get into big data field as a data engineer, you need to either learn Python or Scala or Java. 2 out of 3 are highly recommended. Okay, Python is getting a lot more popular in developing ETL, in implementing ETL using a programming language. Scala is similar to Python. Java is more object-oriented programming. Java will not be used that much for processing data in background. But if you have already Java background, you can continue exploring that even in big data. Otherwise, you can ignore. Okay, R and Go. Go is a different programming language. It's Google's programming language, similar to Python or Scala. It's kind of a scripting type of language. It is not very popular in big data. So I will highly recommend either Python or Scala or Java if you already know Java. If you don't know Java, then ignore it and focus on Python and Scala. If you want to be a big data engineer, if you want to be a application developer using big data systems as the databases, even if you learn Python, you need to know frameworks around Python to build web applications, frameworks in Scala to build web applications, frameworks in Java to build web applications using big data systems as databases. So if you want to explore Python, you need to learn Django. If you're using Scala, you need to learn Play. If you're using Java, you either have to learn Spring or some other framework to work with the underlying databases. Okay, I hope I have answered your question, Shashank. If you have any question, you can ask me. So I will take 3 questions from now from WebEx, and then 3 questions from Hangout. Okay, so Arun Prasad is asking, is the Hadoop ecosystem still evolving? Is it good to wait for some more time until all the tools get consolidated before learning Hadoop or big data? No, you should not wait. You have to start immediately. Even if it changes, unless you build expertise by focusing on fewer technologies, you will not be able to understand those advanced technologies. So you have to start immediately, and you have to add big data in your kitty. Whether you get a job specific to big data or not, it's a different story. But you need to have big data in your kitty. Prakash have asked what should be the next step if interested in towards becoming big data developer. I'm planning to conduct a next online class probably in December or January, starting from December or January. I will circulate a form. I think I already have a form. So if anyone of you are interested in learning big data from me in a live class will cost you money. It's $350. If you want to learn for free, you can go to my website or my channel and you can start watching the videos. But for the live classes, if you are interested, you have to for UK and EU, you can fill this form. For for others, you can fill this form. I will add these two things also in the blog. You can go to my blog and fill this. I will also send a link here. For India and US, you can fill this form. For UK, EU and all, you have to fill the other form. And these are the things which will be covered if you want to be part of my live course. If you are a student, I'm a student, it is free for you, absolutely free. And you have to follow my self-paced course. And weekly on Monday morning or India time or Sunday night US time, I'll be conducting a Hangout or WebEx session where people can ask the questions to troubleshoot their issues, etc. Okay. So any other question? Meanwhile, I will go to the Hangout. So Kunal is asking what is the WebEx password. Kunal, there is no WebEx password, Kunal. You just have to use this link. Anyway, we are almost at the fag end. You can ask the questions in Hangout also. So please share my blog. If you like the content, please click on the like button if you are on a Hangout, and help me reaching out to more and more people so that they get best out of my platforms at free or very low affordable cost. Okay, I will be focusing on publishing more and more content covering vast array of technologies on my platforms. So I will give you 10 seconds. If you have any question, if you have a long question, please say that you are asking a question, and then you can ask a question. Okay. Are you planning for data warehouse workshops soon? Yes, I will be doing a lot of workshops online. It could be performance tuning workshop, it could be data warehouse workshop, it could be Scala programming language workshop. I will conduct at least one workshop every month starting from December. Ganesh is asking which is your recommended certification. If you are, again, go to my blog, which I have pasted earlier, to understand that question, to get the answers. I have explained all the certifications in one blog, and you can decide. But to give a straight answer, if this is your first certification, I will highly recommend CCS, Spark, and Hadoop Developer. So hold on the questions. I will not be taking any more questions. We are almost done. So one question is, Pratpalnis have asked me, to set up Cloudera VM at least need 16 GB RAM. That is correct. You have to use 16 GB RAM. I am planning to build a lab at affordable cost. It will cost you around $55 to $60 for 6 months. If you are interested in that, please fill the form. Yeah, I pasted links just above. Okay, these are the links for the blogs on certifications. Okay, either you need to answer Raghu's question, either you need to have i7 processor with 8 GB RAM, or 16 GB RAM, quad core, or you have to enroll for a lab on a cloud, and I will be building a lab. If you are interested, there is a so you go to any of my pages. There is a big data lab interest form. You can click on this form, and you can fill the form. Okay, you can fill this form. As of now, I have 237 respondents. I'm looking for at least 400 people to respond. Once I get those many people, I will start building the lab at affordable cost, so that people don't have to invest in an expensive laptop. So Arun is asking, how many weeks or months does it take to finish CCS certification for an experienced DTL BA developer? Arun, I know you personally, so I think it should be done with 80 hours of preparation. 80 hours of preparation for you. For others, it might take anywhere between 60 hours to 160 hours, depending upon the variables. If you are a mainframes developer, if you want to do the certification, it will take a lot more effort for you to understand the terms and get certified. So it all depends upon your background and your experience. The time can be significantly vary. Typically, it takes 60 hours to 160 hours to prepare for CCA, Spark, and Hadoop developer certification. So when you are preparing for the certification, if you need any support, I have a LinkedIn group called ITversity-certifications. Okay. ITversity-certifications. The group is 1,500 members as of today. It just started in January. And all of them are IT professionals. And there is no spam in this. Okay. Only discussions that happens in this group is related to certifications. And you can see that a lot of guys have already cleared the certifications. I have actually captured the information in one of the form. So once you complete the certification, make sure you fill out this form, ITversity certified professionals, because I want to get into staffing later. So this is the report. So you can see 48 guys actually cleared CCS Spark and Hadoop developer. These are only acknowledged. There are many guys who haven't acknowledged. As per my estimate, at least 150 people have cleared all the certifications, and you can see that people have cleared several certifications following my content. Okay, so if you are interested in preparing for big data certifications, be part of ITversity certifications and also ITversity Big Data. Okay, these two are the groups. So big data will be purely for big data. Certifications is for all the certifications. As of now, the activity is only on big data, but eventually as I upload more and more content, there will be people who certified in other areas also, or who are interested in getting certifications in other areas also. So I am trying to build a common platform for everyone. Okay. So that being said, it seems there are not much questions. Thank you very much for everyone who joined this session. As I have mentioned to you earlier, if you like the content, please click on the like button. Please share the blog. Let me go to the blog. So this is the blog. Please click on this and share it so that it reach out to more and more people. And also stay tuned. There is a lot of free content which you can leverage. And if you are interested in blogging, please send me an email with the subject as blog, and I will follow up with you, and I will try to leverage your talent to create good quality content for all IT aspirants going forward. That being said, thank you very much. I hope you enjoyed the session, and I will be doing a lot of workshops like this. Hence, stay connected with me on Meetup. So people who have joined on YouTube Live directly, if you are not on Meetup, please join this Meetup group called ITversity In, and be part of my workshops, which I will be creating once every month starting from December. I will decide on the topic, and we will do a workshop on that. It will be a big workshop, 3 to 4 hours workshop, where you will learn something or the other in each and every workshop. Okay, thank you very much. Bye. Okay, for Hangout, guys, there might be a little bit lag, so I'm waiting for some time. And then thank you very much for joining the session once again. And also make sure you join my meetup, as I have explained earlier, meetup.com/itversity-in, so that you get invitation. Workshops typically I will do on WebEx, and I will do the similar thing. I will do on WebEx, and also I will be announcing on Hangout, so that the video is streamed and you will have it for reference. And also people who join on the Hangout will know about me, and eventually I will build the pool of it. So if you are not part of the meetup group, please add yourself to this, and I will be announcing the workshop at least 3 weeks ahead of time. And I would like to pool at least 100 or 150 RSVPs for each and every session, so that at least 30-40 guys will join the WebEx session and get value out of the workshop, which we will be doing once every month starting from December. That being said, thank you very much. Have a nice one. Bye.